thank you for watching this video. So in this video we're doing question 3 of May, June 2024 question paper mathematics paper 1. The topic is the quadratic and arithmetic patterns and sequences. So let's go. Question 3. 3.1. Consider the quadratic number pattern. So they wanted to think about this quadratic number pattern. So we are told that 3, 7 and 12 form a quadratic number pattern. No problem. So at 3.1.1, that's saying show that the general term of this number pattern is given by Tn is equal to half n squared plus 5 over 2 n squared. Sorry, they are saying that at 3.1.1, that's saying show that Tn is equal to half n squared plus 5 over 2 n, not n squared. So they've given you a quadratic number pattern. They wanted to show that the general term for this number pattern is this one. No problem. So let's go and investigate that pattern. So in that pattern we have 3, we have 7, and we have 12, and then it continues that way. So we first find the first difference. This is our first difference here. 7 minus 3. What is the answer to that? It's 4. 12 minus 7, that is 5. This is the first difference here. First difference. Right? The second difference, here is it. This is the 5 minus 4. This is 1 here. This is what? This is your second difference. That's what we have. So what they wanted to find, they wanted to find the general term. So, a general term of a quadratic sequence is in the form Tn is equal to an squared plus bn plus c, right? No problem. So you need to find a, b, and c. Or you need to prove that a is equal to half and b is equal to 5 over 2 and c is equal to 0. So what is a? How do we find a? So your a is equal to half of d. What is this? D. This d is the second difference. The d, a is equal to half of d, and d is the second difference. What is our second difference? Our second difference is 1. So our a is equal to half of d, which is what? Which is 1, because second difference, 1. So you get that your a is equal to 1 over 2, which looks similar to that. Right? So what do you do with this half? With this half, you put it on this equation so that you're only missing, you put it on the nth term so that you're only missing b and c. So let's do that. So we say, okay, what do we have? So we say our Tn now, we said it was an squared plus bn plus c. We have a to be a half. So in the place of a there, we're going to put a half. So it's going to be half n squared plus bn plus c. That's what you have. So which means you've proved this part, so you have to find b and c now. So how do we do that? We say, okay, what do we have now? We have the first term, second term, and third term. So let's try to find the first term in this thing here. So if we want T1, we're going to put 1, substitute 1 there and there. So we're going to have half of 1 squared. So in the place of n, you put 1, right? Because you want the first term. So it's 1 of n squared plus b of 1 plus c. If you simplify this, you find that your T1 is equal to half times that is going to be half plus b plus c. But you have T1. What is your T1? Your T1 is equal to 3, so you can put 3 there. So your 3 is equal to 1 over 2 plus b plus c. Let's transpose this to the other side so that the numbers are together. So you have 3 minus a half is equal to b plus c. What is 3 minus a half? 3 minus a half is 5 over 2. Right? Is equal to b plus c. This is what we have at this very moment. Actually, it's not 5 over 2. It's 3 over 2. This is 3 over 2. That's what it is. So, we did this. So we have an equation that have 2 variables. Let's go and try to find another equation. that might help us to find the values of B and C. You do the same thing but for the second term. So let's go and find the second term. So your T2 is equal to, first Tn is equal to what? Half n squared plus Bn plus C, because you use the same skeleton that is partially filled. So your T2 is equal to what? Your T2 is equal to half, put 2 there, plus B times 2 plus C. So your T2 is equal to, this should be squared. So this is, punch this on your calculator, this is 4. 4 times a half is 2, plus 2B plus C. But you have T2. Your T2 is equal to 7. So you can say your 7 is equal to 2 plus 2B plus C. Then take the numbers to the same side, the way you did here. So you get that your 5 is equal to 2B plus C. So you have two equations, this equation and that equation. So you can solve these equations simultaneously, right? And these are linear equations. So what do you have? You have 5 is equal to 2B plus C. And the other one is what? Is 1.5, right? Is 1.5 is equal to, what is it? B plus C, right? That's what you have. So what do you do? Oh, actually, I think we made a mistake. Wait. Okay, no problem. So let's subtract here. So you say your 5. No, something is not okay. Something is not okay. This here was supposed to be 5 over 2. Sorry, 5 over 2 here. And this is 5 over 2. So if you punch this on your calculator, you find that this is 5 over 2. Punch this, because it's going to be 2,5. I made a mistake. So this is 2,5, which is 5 over 2. So now what do? We eliminate from here. This minus this, or you can solve them simultaneously. You know how to solve a simultaneous equation. Solve for your C here and substitute your C, then solve for B. But I'm going to eliminate. So I'm going to subtract this. 5 minus 5 over 2. The answer is 5 over 2 is equal to your B, 2B minus B is B. Your C minus C is 0. Therefore, your B is equal to 5 over 2, which is the same as that one over there. Right? No problem. Then what we're missing is a C. So to find a C, to find the value of C, you can take this B, substitute on the first equation or the second equation, and then solve for your C. So I'm going to take this one. So I said 5 over 2 is equal to B plus C. So 5 over 2 is equal to B. What is B? B is 5 over 2 plus C. Therefore, take this to the other side, so these two will cancel out. You get that your C is equal to 0. Therefore, your Tn is equal to half n squared plus 5 over 2n plus 0. So this is your nth term here, which is the same as that one. So we have proved it. We've proved it. So we're done with this question. We're going to move to the next one, which is 3.1.2. So I'm going to clean the board and do the point number 2. So let's go. What must be added to Tn minus 1 so that Tn is equal to 13,527? So you are given that a Tn to be equal to what? 13,527. This is what you're given. You're given this Tn here. So they're asking what must be added to tn minus 1 so what must be added to tn minus 1 so that it is equal to tn? This is what these people are asking. They're asking this thing here, D. What must be added to tn minus 1 so that you get tn? That's what they're asking. So, here's what we need to understand. So, if you have a sequence, right? Let's say I give you a sequence of numbers, right? It starts here at T1, right? It continues. Let's say maybe you get to T19, right? The next term after T19, directly next to it, it's going to be T20, going to be T21, and so on, right? So, from the first term, the term after it is going to be T2, you add 1. If you want the next term, you add 1 to this, to be T2, add 1 to this, T3, 1 to this, T4. So if you have T19, right? T19, the term after it is going to be T20 because you have to add 1 to get to T20, add 1, T21, add 2 to get T23. So if I'm telling you about some number Tk, let's say there's a number Tk here, right? Tk is here. The number after Tk, you have to add 1 to the k. So the number after Tk, it will be Tk plus 1, the number after this. And the number after Tk plus 1, it will be Tk plus 2. You add 1 to that subscript there. So the next one will be Tk plus 3. And the list goes on. Because you say if S19 is going to be 20, you add 1, you added 1 from this to that. From this to that, you add 1. So if you have Tk there, the next time is going to be Tk plus 1, after Tk plus 2, after Tk plus 3. No problem. So let me clean this Tk here and put it here, this Tk here. So the question now is what is the number before this one? But look, here you had Tk plus 3. Here this is Tk plus 2. This is Tk plus 1. And this is Tk plus 0. So it's like if you're moving to this direction, you're subtracting 1 to get the term before it. But if you're going forward, you are adding 1 to the subscript so that you can get the following term. So what is happening here? If you want the term in front of Tk, so it should be Tk minus 1. This will be the term in front of this of Tk. And if you want the term in front of Tk minus 1, it should be Tk minus 2. And so on. So in this case, you are given nth term Tn, right? And you're told that Tn is equal to 13,527. That's what you're given. And then now, they are telling you about Tn minus 1, right? Tn minus 1 is the term in front of this one. So it's Tn minus 1, and then it will be Tn, because if you are sitting at term Tn minus 1, the term in front of it should be plus 1 of that. So if you add Tn, if you add 1 to n, if you add 1 to this n minus 1, the next term, it will be Tn. Right? So the point that I'm trying to explain is that these terms are terms that are sitting next to each other. Like Tk and Tk plus 1. Like Tk and Tn minus 1. So this is the situation that we have here. So you have a term Tn, right, that you are given. So the term in front of it, it will be Tn minus plus 1. So the term after it will be Tn minus plus 1. The term before it, it will be Tn minus 1. So you are given the value of this term here to be what? You are given the value of this term to be 13,527. That's what you are given. You are given that the value of this term is 13,527. So they are asking what must be added to the value that is here so that you get that. They're asking what must be value added to this term here so that you get that value over there, which is 13,527. So how do you do that? What is important to know is the position of this term here. Go and find the value of n. If you know what the value of n is, then you will be able to know the term, the value of n minus 1. Then you will be able to find Tn minus 1. Let's say we find the value of n and find that the value of n is 7. The term here is term number 6. And the term this side is term number 7. No problem. Okay, I'm not sure if that was correct. But let me try to make an example again. Let's say now this is term number 6. The term here, this will be term number 5. Right? Because it's after it, it's before it. And the term after it will be term number 7. Because it's after our 6. Right? No problem. So what you need to find the value of n there. So that you know what position is this one. So if you know the position of this and know the position of that, then once you know the position of this, you can find its value on the nth term that you are given. After finding this value, then you will know what you need to add so that it is equal to that. So let's do that. So here's what I'm going to do. So I'm going to equate, so we have the nth term to be equal to half n squared plus 5 over 2n. So go and find the value of n, the position of this term here, the position of this term. So we're going to substitute our 13,527 here. So 13,527 is equal to half n squared plus 5 over 2n. Right? Want to solve for n, so put this on your actually, let me transpose this to the other side. So you have 0 is equal to half n squared plus 5 over 2n minus 13,527. That's what you have. So you can put this on your quadratic formula straight away. Right? You can put this in your quadratic formula straight away. Or you multiply by 2 throughout. If you multiply by 2 throughout, so this will be times 2, and all of this will be multiplied by 2. So 2 times 0 is 0. So this times 2, it will be n squared plus 5n minus the double of that. 2 times that, that's what we're going to get on our calculator. 13,527 times 2. You get that your answer is 27,054. So you can find the value of n. So n equal to negative b over 2a. Or negative b plus or minus square root of b squared minus 4ac all over 2a. So our n is equal to negative b. What is our b? Our b is 5 plus or minus the square root of b squared, which is 5 all squared minus 4a. What is your a? A is 1. And your c is equal to negative 27,054. All divided by 2 times a. What is your a? A is 1. So your n is equal to, or your n is equal to, punch that and see what you get. So negative, so it's negative 5 plus the square root of 5 all squared minus 4 into a into negative 27,054 over 2 times a. You get that your n is equal to 162. Or your n is equal to what? Negative 167. Right? So these are sequences. And you know that on your sequences, your n is a what? Is a natural number. Which is numbers that are starting from 1, 2, go forward. So this can be, because natural number is negative. So what this is telling us, it tells us that T162 is equal to what? 13,527. So this term here is 162nd term of the sequence. The term next to it is term. So if you have T162 here, the term in front of it, ahead of it, it should be term 161. The term after it should be term 163, this one. So you know the value of this one, that is 13,527. So what you need to find, go and find the value of T61. Then you will see what you need to add to this value so that you get this. That's what you ask to find. So let's go and find T161. T161 is equal to 1 over 2 into 161 all squared. That's 5 over 2 into 161. This was your Tn. So your T161 is equal to the answer to this. So let's go. So 0.5 into 161 all squared. That's 2.5 into 161. So you get that T161 is 13,363. So you have these terms sitting like this. So here you have 13,363, and here you have this one. So they're asking what must be added here so that you get that. What should you add to this term so that you get that? So it's more like they're asking what is the difference between these two terms. That's what they're asking you essentially. No problem. So we say that on T161, which is behind our T1, which is in front of our T162, is 13,363. We must add some difference so that we get what? The next term. So they're asking what is the difference essentially between these two terms. 13527. You can solve for your D. So your D is equal to 13,527 minus 13,363. Therefore, your D is equal to the answer to this. So you say 13,527 minus 13,363. So this is 164. So, which means on T161, 164 must be, a value of 164 must be added on T161 so that you get that. That's what these people are asking you. That's what this question is asking you. So we're done with 3.1. It's like this. So I'm done with it. So the value that must be added is 164. So I'm going to go to the next question. We're done here. Okay, so now I'm done cleaning the board. So we're doing 3.2. So 3.2 read as follows. Given an arithmetic sequence with T1 equal to 8 and T2 equal to 11. So you are given an arithmetic sequence here. So here the terms T1 is equal to 8 and T2 is equal to 11. So these two terms form an arithmetic sequence, right? No problem. They're saying calculate the value of n if Tn is equal to 41. So they want us to find the value of n if Tn is equal to 41. So how are we going to do this? You know the general term of an arithmetic sequence is Tn is equal to a plus n minus 1 times d. Right? So Tn we're given is 41, no problem. A is the first term, which is 8, and d is the common difference. So let's go and find the common difference. So we have the first term to be 8, the second term to be 11, and so on. So the difference between them is 3. So this is your common difference here. So this is equal to your d. So you have d as well. So you're only missing a. So Tn is equal to 41. So you put your 41 there. It's called a, which is 8, plus n minus 1 times d, which is the difference, 3. Transpose this to the side, you get 33 is equal to 3 into n minus 1. So 33 is equal to 3 times n is 3n minus 3. And transpose this to the side, you get that your 36 is equal to 3n. Then divide by 3, divide by 3. Therefore, your n is equal to 12. This should be 12. So, which means the term 41 is the 12th term of our arithmetic sequence. And we're done with this one. So, let's go to 3.3.2. There's A and B. No problem. What are they saying? They are saying a new sequence. 3.2.2. An arithmetic sequence P is formed using the term position and the value of the given arithmetic sequence. Let me read this thing again. They are saying a new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. For a new sequence, P1 is equal to P8 is equal to 1, and P11 is equal to 2, and so forth. No problem. So they are saying there's a new arithmetic sequence that is formed. And it is formed with the term position and the term value. So what is happening is, you see here, you have term 1 to be 8 and term 2 to be what? 11. So here, things are changed now. You have another sequence P, right? So P Now, so P of 8 would be equal to what? That value there is 1. And P of 11 is equal to 2. That's what they're saying. So it's more like these things are reversed, these numbers here. So this one sits here and this one sits there. This one sits here and this one sits there. So P of 8, so you had T1 to be 8, right? So here the 8th term here will be 1. You had T2 there to be 11. So which means here the 11th term would be 2. They have switched these things around. No problem. At 3.2.28, they're saying write down the value of P41. So they want us to find P41. This is 3.2.28. They want P41. What is P41? So on the previous question, we found that n is equal to 12, the value of n. What does this thing mean? It means that your T12 is equal to 41, which means that value of n is 12. So if they said find n, here's n, which means T12 is equal to 41. So if they want T41, we know these things are swapped around. So which means your T41, right, should be equal to what? Should be equal to 12. Just switch these things around the way they did that. And you're done with the first one. We're done with the first one. So we'll move to the second one, which is B. What are they saying with B? They're saying calculate the value of the first term of the new arithmetic sequence. So they want us to find the first term of our arithmetic sequence, this one and that one. So we were given T8 to be 1 and T11 to be 2. So they want the first term of the sequence here. No problem. So we know that Pn is equal to A plus n minus 1 times D. That's what we know. So if we want to find P8, we'll put 8 here and put 8 there. So your P8 is equal to A, which is what we want to find, because we want the first term, plus n, which is 8 in this case, minus 1 times D. D we don't know. Right? We don't know what D is. No problem. So we say P8 is equal to A plus 7D. Right? But we know what P8 is. P8 is 1. So we say 1 is equal to A plus 7D. So here's the first equation. You can find the second equation doing the exact same thing. But now for P11. So we said that Pn is equal to A plus n minus 1, because this is the general term of an arithmetic sequence times D. So we want P11, right, is equal to A plus 11 minus 1 times D. So if you simplify, you find that P11 is equal to A, which is what we want, plus 11 minus 1, that's 10. So that's 10D, right? So what is P11? P11 is equal to 2. You put 2 here. It's equal to A plus 10D. So you have two equations. This one here and this one there. So you can solve both of them simultaneously. That's what we have to do. So what we can do, we can put this one underneath this one and put a 1 here. It's equal to A plus 7D. And then you solve them simultaneously. I'll eliminate. Minus 2 minus 1 is 1. A minus A is 0. And D minus 7D is 3D. Then divide by 3, divide by 3. Get that your D is equal to 1 over 3. So here's your D. Once finding D, you can find A on the first or second equation, whatever that you like. So what you'll do, I'll take the first one. So 2 minus A plus 10D. 2 is equal to A plus 10D. So we know what D is. D is 1 over 3. So 2 is equal to A plus 10 into 1 over 3. So you transpose this to the other side. So 2 minus 10 over 3 is equal to A. And this looks like it's equal to minus 4 over 3. So that is the value of A. So the value of A is equal to minus 4 over 3. And I hope it does make sense to you, as it does to me. So I'm done with question 3. 15 marks. pocketed, I hope. Thank you.